Okay, so today in 6.4, we are going to work a little bit called probability. Now, you've dealt with probability probably quite a bit as you've dealt in life. You may not realize it, but many things deal with probability. Anything from the crazy weather that we've been having, maybe 30% chance that something will occur. That's probability. Um, because we're dealing with probability, we've got to do a little bit of work on definition. So the first is that an experiment is just an activity in which the result is random. This could be anything within this section: rolling dice, selecting cards out of a deck. We're going to deal with quite a bit, but they're just experiments. They're things that we can test that are random in nature. An outcome is simply an individual result of some experiment. So an outcome, we're going to have multiple outcomes as we start working on rolling dice and things like that. But every time we get a result and we get we get a result. Every time we roll a dice, for example, we're going to get either a heads or a tail. If we were to flip a coin, we would get a head or a tail. This would be an outcome of an individual experiment. So flipping the coin would be an activity that would result in some sort of a random result, and then each of those random results that occurred would be our outcome. Our sample space is the set of all possible outcomes of any experiment. For example, if we were to roll a coin, then we are going to get that either not roll a coin. If we're going to flip a coin, then we're going to get that either we're going to get a heads or we're going to get a tails, right? If we flip a coin once, then this is the only outcome that we could get for our experiment. So this would be our sample space. Let's just label it S. Okay, and that's going to be our sample. We either get a head or a tail. Now, it could get much more complicated than that as we get larger and larger experiments, but in its basic set, that is our sample space for rolling a dice once. Okay, and the event is some, and we could say or all of the outcomes in a sample space. So, for example, here, if I had said I only want the chances of getting ahead, right? Well, that would be one event within that sample space. I could say I want the heads or tails. Well, that would be two if I had selected both. Okay. We tend to be able to visualize anything that we do with probability with something called a tree diagram. And let's just take, for example, that we're flipping a coin. Let's flip it 3 times, and let's see what happens when I flip a coin 3 times. Well, on the first flip, we're either going to get a heads or a tails, assuming that you have a perfectly fair coin, right? Then we're going to either get a head or a tail. Well, that is our first, that is the first experiment that I do. But now let's flip it again. So if we had flipped it the first time, actually, let's go ahead and do that in red so we can tell the difference. So let's go with red for our first. So this was our first roll that rolled a head or a tail. Well, then let's say we roll again. Well, if we roll heads, then the second roll could come up with a head or a tail. If we had rolled a tail, we could also come up with a head or a tail. And that would be the second roll. Okay, so that's the next thing that could possibly happen. Now, for our third flip, we could have had the head or the tail. Let's go ahead and do blue for the second roll. So our second roll could have been a head or a tail, or a head or a tail. Well, from here, we could even go a greenish, because we're starting to get a little close quarters here. We could do from here a head or a tail. It won't matter which one I go first, tail or head. We could do a head or a tail, a head or a tail, or finally this last one we could do a head or a tail. Now, so what this is doing is now we can read down each line. So here's head, head, tail, or head, tail, head, or head, tail, tail. That should have been, sorry, head, head, tail, or head, tail, head, head, tail, head, head, tail, head, tail, etc., 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 throughout the diagram. And what this does is it lets us generate that sample space that we could be working on. Okay. So the event that we're going to be working with, if we were to select, so let's select all the probabilities. Select all the probabilities that something will happen. Something will happen. If, for example, if we were to take a look up here and we were to select all probabilities in which 2 heads are rolled, that would be an event. That would allow us to calculate the probability. So at what point are 2 heads rolled? Well, nothing from the first flip. We get a head, head, or head, tail, or tail, head, or tail, tail. Well, at what point were there 2 heads rolled? Right here, just one. And then here, 2 heads were rolled. Here, 2 heads were rolled. Here, 2 heads were rolled. Here not, here not. So what I'm going to be doing, if I'm selecting that, then I can select that number out of my entire sample space. Okay? So what we do is we're able to find the probability of an event occurring. So my probability of an event occurring is the number of outcomes that are in an event above divided by the number of outcomes in a sample space. So probability is the number of outcomes in the event, okay, that's what I want to happen, remember, divided by the total number of things that could possibly happen. Now, probability actually has 2 basic characteristics, and they are as follows. Probabilities fall, they fall between 0 and 1. So, okay, so let's think about this. Probability is a percent, right? Because it's a part out of a whole. So it makes sense that a probability is going to fall between 0 and 1. So if the probability is 0, then the event will never occur. If the probability is 1, then the event will always occur. Okay. The other thing that we need to know about the probabilities is that the sum of all probabilities or probabilities, sum of all the probabilities of all the outcomes is 1. Well, that makes sense too, because I have if I have a certain percent, let's say that my percent for heads is going to be 50%. Well, it would make sense that if the percent for heads is 50%, then the percent for tails will be 50% too, which then of course will add up to that same 100%. Well, that's all the lecture that I have for this. Let's go ahead and jump into a few examples.